Hello all, welcome back to my YouTube channel. In last video we have seen in the last video we have already covered UDS protocol. So in UDS protocol I have mainly covered all the important service IDs, and I didn't cover all the UDS service ID, only the important ones which are primarily used in infotainment testing and cluster testing or diagnostic testing, which that I have covered. For example, 10 service ID 10, diagnostic session control DTC, read data by ID, write data by ID 2220, 2E3 and 2811. So all this I have covered only. So in the next series I will be covering CAN protocol. So in CAN protocol, so these CAN frames, in CAN frames I will cover types of frames, active and passive error frames, then CAN error detection, error type, CRC, beta stuffing and all, REC, CAN synchronization, NRC, non-return to zero, bus synchronization, time quantum and many more. So the sorry. So the first one is types of frames. So types of CAN frames. So there are 5 types of CAN frames: data frame, error frame, remote frame, overload frame, and interframe space. So all this I will be covering in the next. Maybe in this video I will be covering data frame and CAN architecture only, and then in the next video I will be covering the remaining CAN types of CAN frames. So let's see CAN frames architecture. So here most of the you might have aware of this CAN frame architecture. So I will tell you about this. What is I'm not going to explain the exact definition of what bus idle, identifier, start of frame they all do. So first I will tell you about their real world scenarios. I will connect with you with a real world scenario, then I will tell you the technical definition of it. So first is bus idle. So bus idle or idle state, you can think of a highway at night with no vehicle, okay, and the road is idle and ready for traffic. Similarly, in the CAN bus, this idle state provides a buffer before the next frame starts. Okay, so that is for yeah. So that is for bus idle. And start of frame, you can think or imagine like imagine the whistle in a race. Starters whistle in a race. The whistle signs the participants to get ready for the event. And the next one is arbitration field. Arbitration field, you can imagine like in a factory multiple machines or nodes may try to send data simultaneously, okay. The machine with the most urgent data, let's say a lowest identifier, will get priority, just like how ambulance have priority on the road. And the next one is control field. Control field, you can think of a shipping label on a package indicating the number of items inside. For example, let's say this box contains 5 items. The DLC helps the receiving node know how much data to expect. Okay, I'm just giving you the real world scenario, then I will tell you the technical one also. And the CRC field, sorry, in the data field here also you can consider in a car's CAN bus system, the data field might carry the vehicle speed, example 80 km per hour or 90 km per hour, fuel level 50% or engine temperature. So that is data field contains. And the next one is CRC field. So CRC field means it is similar to double checking your grocery bill by recalculating the total to ensure no errors were made during addition. And the next one is acknowledge field. Acknowledge field means imagine sending a text message to your friend or girlfriend and receiving a delivery status. So this acknowledgement confirms the message was successfully received, like we have seen in the WhatsApp or Instagram whenever we send any message to our friend. And the second last one is end of frame. Think of saying goodbye. So it signifies that you have finished speaking and you and are ready. So end of frame means it is like think of saying over at the end of a walkie-talkie message. It signifies that you have finished speaking and are ready for a response. And the last one is ITM or interframe space intertransmission message. Consider a teacher giving a short pause between questions during a quiz, allowing students to think before moving on to the next questions. So for all this, I have given you the real world example. You can think. So if I talk about the technical definition of idle state, so when there is no frame on the bus, so the bus is in idle state. Okay, so in the idle state, the bus has a recessive bit. Recessive bit means 1, dominant bit is 0. And the next one is start of frame. So start of frame means every data frame starts with a dominant bit. Okay, dominant means that is 0. 0 is your dominant bit and 1 is your recessive bit. Think of remember this. So this bit informs all nodes about the start of a new frame on the bus, signaling that the bus is no longer idle and synchronizing all receiving nodes with the transmitting node. And the message ID, this one, identifier. So it has two identifier for currently I am talking about standard remote frame. So it has 29 to the power 11 bits, means 11 bit identifier I am talking about. So so this standard frame will be used for cars and cars and extended CAN frame will be used for trucks and heavy vehicles. So ID, so CAN is as you all know, CAN is a message based protocol where each frame is identified by a message ID. That's why here it is identifier. Okay, so here message ID is 11 bits long. So typically the 11th and 4 bits are masked for complex reasons, resulting in 9 unique bits in the message ID. So to the power, so this allows for to the power 9 is equal to 512 different CAN frame in a single CAN network, with the message ID ranging from if you take hexadecimal 0000 to 7FF. And the next one is RTR. RTR means remote transmission request. So after the message ID, there is a single bit called the remote transmission request. Here you can also here I have given a screenshot for this dominant in data frame, recessive in remote frame. So this I will talk about later. So in a remote transmission request, after the message ID, there is a single bit called the remote transmission request. So RTR differentiates between a data frame and a remote frame. So 0. So if it is 0, then it is a data frame, and if it is 1, then that is remote frame. And this is the idle state. So reserved bit. So idle is nothing but a R1, and this R is R0. So these bits are always recessive and were originally intended for future enhancement of the CAN protocol. So nowadays R1 is used as the idle bit to differentiate between standard and extended frames, while R0 is used as the FTF bit to differentiate between CAN and CAN-FT frames. So this reserved bit, it has 2 bits, must be dominant. Dominant means 0. And the next one is data length code. So which it indicates the number of bytes of data in the frame. So DLC is 4 bits long and can range from 0 to 8, allowing for up to 8 bytes of data. So here it is 8 bits long, and also this is for standard CAN. I am talking about for standard CAN. So if you select 8, then in the data field you can send 8 bit. data, 8 bytes of data you can send in the data field. And here frame is data frame. And if you select 9, then it will only 8 bytes you will see here. But if you select 5, then this 2 will 6 and 7 will be disabled, only 5 bytes will show. So this is the DLC data field. So following the DLC is the actual data field, which contains the data bytes specified by the DLC. So the data field can contain a maximum of 8 bytes and a minimum of 0 bytes. Okay. And the next one is CRC field. CRC field is total 16 bits. So 15 bits CRC cyclic redundancy check. So it and 1 bit is for this delimiter. So CRC field used for error detection. So the transmitting node computes the CRC checksum and includes it in the frame. The receiving node also computes its own checksum for the received data and compares it with the CRC field. If they match, the frame is considered valid, otherwise it is valid. Let's say if you are sending data AB, okay, and here is CRC, and receiving and you are getting BA. Okay, so it is not matching. That will give CRC error. Okay, so in that case it will be a invalid bits. And following the CRC field is a CRC delimiter, a single bit used to provide time for the receiver to validate the frame. Okay, so here you can see CRC 15 bits and CRC delimiter 1 bit must be recessive. Okay, then the next one is acknowledgement. So acknowledgement, so transmitting node puts a recessive bit in the acknowledgement slot. All receiving nodes for let's say A to B is the receiving nodes that successfully received and validated the frame. And validated the frame will override this bit with a dominant bit to acknowledge a receipt. If the transmitting node, let's say A, doesn't see a dominant bit in the this acknowledgement slot, it signals an acknowledgement error. And following the acknowledgement slot is the acknowledgement delimiter, a single recessive bit. Acknowledgement transmitter sends recessive and receivers sets dominant. So here transmitter, if it doesn't see dominant bit in the acknowledgement slot, then there will be acknowledgement error. And this is a acknowledgement delimiter, a single recessive bit. And the next one is end of frame. So end of field consists of 7 consecutive recessive bits, that is 1, marking the end of the frame. Okay, so here if I show you end of frame, must be recessive, 7 bits. Then ITM, inter transmission message or interframe space, whatever you alternatively you can say. So the end of field is followed by 3 bits of interframe space. So these 3 bits signify the end of the frame and the bus returning to the idle state. So if I talk about this composition, so arbitration field, it consists message ID and RTR. Control field, this controls this takes result bit R1, R0 and DLC, and CRC field takes CRC checksum and CRC delimiter. Acknowledgement field, acknowledgement and slot and acknowledgement delimiter. And end of field, it takes end of file and interframe space. So every data frame ends with 11 consecutive recessive bits. Remember, every data frame data frame I am talking about ends with 11 consecutive recessive bits, 1 bit of acknowledgement delimiter, 7 bits of end of file, and 3 bits of interframe space. So once the frame ends, the bus is idle. Again, and any node can start transmitting its own frame in that case. So this is the overview of the standard CAN frames. So by using real world analogies like traffic system, factories, and common daily tasks like ambulance, you can make the CAN frame format. So so like this you can easily understand this one. Next one is CAN frame DLC that I have already explained. DLC, yeah. So here, so for this you can take a screenshot. Okay, I will remove this erase. So this one you can take a screenshot. Start of frame 1 bits. Sometimes in interview they ask question about the bits. How many? Let's say what is the bits of DLC or CRC? How many bits CRC contains or CRC delimiter contains? So you can take this screenshot and you can remember this whether it is recessive or dominant. So like this. So this is the CAN frame architecture. So in the next video I will explain error frame remaining this.